So we started talking about solving equations in the first section, 1.1. We solved equations using addition, subtraction, multiplication, and division. Now we're going to combine those. We're going to do multi-step equations in 1.2. So let's take a look at the top of the page, the core concept, solving a multi-step equation. The key here is that we are going to solve this equation, and in order to do this, we're going to isolate the variable using inverse operations. Inverse operations, that little vocab word should sound familiar from 1.1. Inverse operations are those operations that undo each other, like addition undoes subtraction and multiplication undoes division. So we're going to use those to help us get the variable by itself, to isolate the variable. So ultimate goal here is to get the variable by itself. Take a look at our first example. 2x plus 3 equals 15. I'm going to first identify where the variable is, right here, x. I need to get that x by itself. In order to do that, I'm going to work outside in, okay? I'm going to undo whatever's farther away from the x. In this case, right off the bat, I'm multiplying by 2. Then I would add 3. So I'm going to undo the plus 3 first. So I'll undo the plus 3. To undo the plus 3, that means I have to subtract 3. Remember, our properties of equality said, hey, if you want to subtract 3 on one side, you got to do it to the other side. So I'm left with 2x over here and 12, okay, because I undid the plus 3. Now, I still have to keep going. The x isn't by itself, so now I'm going to undo the 2 times x. I undo multiplication by dividing, so I'll divide both sides by 2, always both sides. Now the x is by itself, and my answer is 6. Just like before, let's do a quick check here. So off to the side, my check would be going back to my original problem and plugging in 6 for x. So that's 2x, that's 2 times 6 plus 3 equals 15. And 2 times 6 is 12 plus 3 equals 15. And hey, guess what? 12 plus 3 is 15, so it checks out. Let's try the next one. Again, I'm going to start by identifying where my variable is and then undoing to get it by itself. So my variable is x again, right here. I'll work outside in, so first I'll get rid of that minus 13. To undo minus 13, I'll add 13 to both sides, always to both sides. So the 2.5x is now isolated, the 13's gone. When I add 13 to the other side, I get 15. I got to keep going. I want to get the x by itself, so I'm going to divide by 2.5, and if I divide one side by 2.5, I have to divide the other side by 2.5. It's always the other side of the equal sign. So some people, kind of going back here, I'm adding 13 to both sides of the equal sign. I don't add 13 over here. It's just both sides of the equal sign. One on this side, one on this side. One on this side, one on this side. So now the x is by itself. 15 divided by 2.5 is 6, so my answer is x equals 6. Again, I'm going to check that, so off to the side I'll do my check. I'll go back to my original problem, which is 2.5x, or 2.5 times 6, minus 13 equals 2. Order of operations says let's do 2.5 times 6 first, that's 15. Minus 13 equals 2, and 15 minus 13 is 2, so it checks out. Let's take a look at the next one, because the next one's going to get a little bit more complicated. What's a little bit more complicated about this next one is now we actually have two variables with the same variable, but we have it twice. We have an x here and here. So we're going to have to do what's called combining like terms. Hopefully you remember combining like terms from a previous math class. Combining like terms means adding anything that has the same variable. So 9x and negative 6x have the same variable, so I'm going to put lines underneath them. And I'm going to add those together, 9x and minus 6x. 9 minus 6 is 3. Everything else stays the same, so it's still negative 12 equals, but now it's 3x, and there's still a plus 15. It looks a little bit like one of the problems in the first example. The only difference is our variables on the right side, this x that I'm solving for. So I still have to work outside in. So the 3 is right next to the x. I got to get rid of the plus 15 first. So when I subtract 15 here, remember, go to the other side of the equal sign. So all the way over to the negative 12, and subtract 15 there. Negative 12 minus 15 is negative 27. And then I still have 3x. I got to get rid of that 3, so I'll divide both sides by 3 so that it'll cancel there. And I'll get negative 9 equals x. If you prefer, you could write it as x equals negative 9. It's the same thing. It just looks a little bit nicer. Okay? Again, when we go back to our check, we have to go up to the very original problem. Before I combine like terms or anything, that's what I'm going to use for my check. So negative 12 equals 9 times negative 9 minus 6 times negative 9 plus 15. So I'm going to, at this point, I want you to grab your calculator or open up Desmos because we're going to check this on our calculator. I want you to type all of this in exactly as you see it with parentheses and negatives and everything like that. And you should be getting, so we already know that this is negative 12, you should be getting that that all equals negative 12, so it checks out. So plug that all in your calculator. From here on out, we'll use our calculator to help us check it, as long as we're using parentheses and everything. Let's try the same thing on the next one. Let's identify the like terms. So 12 and 18 are not, we cannot combine those because they're on separate sides of the equal sign. We can only combine things that are on the same side. So let's take a look at this left side. We've got a negative 2x, a negative 10x, and a 12. Which ones are like terms? The ones that both have an x. So I'll combine those two. Negative 2 and negative 10 is negative 12x. I still have the plus 12, and I still have the equals 18. So let's go ahead and solve this. I need to get the x by itself. I'm going to get the x by itself by subtracting the 12 first. It'll cancel on the left side. And I'll have negative 12x equals 6. Then I'll divide by that negative 12 on both sides. You actually will get a decimal here. 6 divided by negative 12 is negative 1/2 if you reduce it, or if you prefer, negative 0.5. Still want to check this, so I'm going to go back up to my original problem and do my check. Again, we're going to use our calculator to check this, so take your calculator out or open up Desmos. It'll be 2 times negative 0.5 minus 10 times negative 0.5 plus 12, running out of space here, equals 18. So we know whatever this is, it should equal 18. So this is what I want you to type in your calculator. Make sure you got the negatives, don't miss any signs, anything like that. When you type that in, you'll get 18. 18 does equal 18, so it checks out. We're going to keep going with the solving multi-step equations. Now we're going to toss parentheses into the mix. So we have to figure out, how do I deal with parentheses in order to solve this? So one way, and maybe the easiest way to get used to dealing with parentheses, is to distribute to get rid of the parentheses. So this might be something you've seen before. Distributing means taking whatever's outside of the parentheses, in this case it's the 3, and multiplying it individually by each thing in the parentheses. So multiplying 3 times x, and then multiplying 3 times 5. After I do that, I can get rid of the parentheses. So I'm going to do that. 3 times x is 3x. 3 times 5 is 15. Notice how I didn't multiply it by the 21 because the 21 is not in the parentheses. So the 21 just stays like that. Now this looks like a problem in example 1. We've got to get the x by itself, and we'll do that by undoing the 15 first by subtracting 15 on both sides. So I'll get 3x equals 6, and then dividing by 3 on both sides to get x equals 2. And again, you know what's going to happen. We're going to check this, and the way we're going to check it is going back up to the originals with the parentheses. 3 times 2 plus 5 equals 21. Again, if you want to plug this in your calculator, just as long as you use the parentheses, it's fine. This one's probably not that hard to do without your calculator. 2 plus 5 is 7. 3 times 7 is 21. So either way you check it, this is 21 equals 21. So we're good to go. We've got 2 more, and then we're going to try a couple word problems here. So let's take a look at the next one. Again, I have some parentheses, so the best way to deal with that is going to be to distribute. Now be careful here. I distribute the 2 to the 1 and the 2 to the negative x, I don't distribute the 2 to the 3 because it's not in parentheses. So the 3 will stay the same. 2 times 1 is 2. 2 times x is 2x. Notice the sign stayed the same. It was a minus, so it stayed a minus. I still have the plus 3, and I still have the equals negative 8. Still a little messy here. I actually have some like terms. There's only one x, so that's good. But the 2 and the 3 are like terms. They're on the same side. Remember, like terms have to be on the same side of the equal sign. 2 plus 3 is 5, so it's negative 2x. Don't forget that negative. Plus 5 equals negative 8, and now I should solve that. If I'm going to get the x by itself, I'm going to undo the plus 5 first by subtracting 5 on both sides. To get negative 2x equals negative 13. And then I'll divide by negative 2 on both sides. Careful with dividing your negatives here. Negative 13 divided by negative 2 is positive 6.5. And you bet we're going to check it back up to the original. And again, if you'd like, you can use your calculator for the check. 2 times 1 minus 6.5 plus 3 equals negative 8. If you're going to use your calculator, when you type this left side, just the left side in, make sure you use parentheses. You'll end up getting negative 8 on your calculator. It equals negative 8, so it checks out. Let's try one more of these. Again, I have parentheses, so again, I'm going to need to distribute. 4 times 2d, 4 times negative 3. The 5 stays on its own because it's not in the parentheses. 15 equals 5 plus, and I'll keep going. 4 times 2d would be 8d. 4 times negative 3 would be negative 12. Again, I have to combine like terms. It looks like my like terms are the 5 and the negative 12. So it would be 15 equals 8d minus 7 when I combine 5 and negative 12. And I'll solve this. I need to work outside in, so I'll get rid of the plus 7 first. So now I've got 22 equals 8d, and I'll solve that by dividing by 8. If you'd like to write that as a decimal, you can reduce it, but if you'd like to write that as a decimal, d equals 2.75. When we do our check, you'll probably want to use your calculator for this. So we know it's going to be equal to 15, or it should be. Do 5 plus 4 times 2 times 2.75 minus 3. Type that whole side into your calculator to get 15 equals 15. Let's move on to our word problems here. So go ahead and turn the page. In our first example, we're talking about a biker. It says, use the table to find the number of miles X you need to bike on Friday so that the mean number of miles per day is 5. So in our table, we have how much you biked on Monday, Tuesday, Wednesday, Thursday. We don't know how much you will have to bike on Friday, but we want the mean number of miles per day to be 5. Mean, let's review that word. Mean is defined as average. We find the average, or the, oops, that's not what I meant to do. We find the mean, or the average, by adding all the numbers together and then dividing by the total number of entries we have. So let's add all of them up together. Let's add 3.5 plus 5.5 plus 0 plus 5 plus x, and then divide by how many we have. Well, there's 5 days there, so I'll divide by 5. I want that mean number to be 5, so lots of 5s there. So now I've got a little equation. First thing, let's combine like terms. 3.5, 5.5, 0, and 5 are all like terms. So I'll end up with 14 plus x divided by 5 equals 5. Now, I say we need to work outside in. Typically, we've been getting rid of addition and subtraction first, but do you see how this 5 is dividing everything? Because it's dividing everything, we need to get rid of that 5 first. To get rid of divided by 5, let's multiply both sides by 5. It'll cancel there, and then I'll multiply the other side by 5. So I have 14 plus x equals 25. Now I'll go ahead and solve that. I'll subtract the 14 on both sides and get that x equals 11. So on the last day, you have to bike 11 miles in order to meet your goal of having an average of 5 per day. Let's take a look at our last example here. It says your school's drama club charges $4 per person for admission to a play. The club borrowed $400 to pay for costumes and props. After paying back the loan, the club has a profit of $100. How many people attended the play? So a good place to start with word problems is to define your variable. What are we trying to solve for, and give it a letter. We're trying to solve for how many people attended the play, so I'm going to call it P. P equals number of people that attended. Okay, so what I do know is that for every person that attended, it cost them $4. It cost $4. So we made $4 per person that attended. So if one person came, we would make $4. If 2 people came, we'd make $8. We can represent that mathematically by doing 4P, 4 times P, okay? However many people came, we make $4 for each of them. We lost some money though, or I guess we should subtract some money. We borrowed $400. So whatever we're gonna make, which is 4P, we're gonna make that money for the number of people that come. We have to subtract 400 because we borrowed that and we have to pay it back, okay? After all that's said and done, we made $100 total, so it should be equal to $100. Now that we have a nice little equation, let's go ahead and solve that. Working outside in, we gotta get rid of the minus 400 first. So I'll add 400 to both sides. It says 4P equals 500. And then I'll go ahead and divide by 4 on both sides. So P equals 125. 125 what? We're talking about 125 people attended the play. So that's it for 1.2, which is solving multi-step equations, specifically also using combining like terms and parentheses.